Solving equations. Right. I think a lot of you might have done this before from previous classes, solving for x. So I'm not going to do too much of this, but I will do one with fraction. Okay. So, one way of doing this. Right. You could just do this. Look. Add a 1. Add a 1. You will then end up with 3/4 x equals, now 1 plus 7/5 is 5/5, that's 12/5. Now that's fractions. Go away and look at that. Alright, and nobody likes fractions. Okay, 5/5, because that's 1, and 7/5 is 12/5. Right, I just added 1 to 7/5. Now, for those of you who remember this, to get rid of that 3/4, okay, we use the reciprocal. Okay, if we multiply by 4/3, don't forget to do it to both sides. Okay, so multiply by 4/3. Then what here is okay, there we go, that's all we did it. These all cancel. You're left with the x. And over here, what's 12? I'll just do it straight across. I mean, you can look diagonally, look what the 12 and 3 divide by. They both divide by 3, alright? Or you can just do 12 times 4 is 48. 5 times 3 in the bottom is 15. Now, to make life easier, I should have divided the 12 and the 3, okay, by 3 in the first place. But now I can do it now anyway. Look, both of these will divide by 3. That'll give you 16/5. Okay, there's the answer. Now that's me doing it that way, but a lot of problems are probably easier done by getting rid of all denominators, okay, and that's multiplying by the lowest common denominator. When you're solving something, either side of an equal sign, you can multiply both sides by, well, let's have a look. What's the lowest common denominator? What's the denominators we have? We've got a 4, we've got a 5. Let's multiply everything by 20. Because if I had multiplied the 3/4 x by 4, I'd have got rid of the 4. If I multiply 7/5, yeah, by 5, I'd have got rid of the 5. So combination of the two, let's use 20. So I tend to write it like this. It feels like doing a distributive law, but look, I just go, right, I'm going to multiply the 3/4 x by 20. I'll multiply it by 20. Minus, I'm going to multiply this 1 by 20. Okay? And I'm also going to multiply the 7/5 by 20. So I'm just going to multiply everything, remember, by 20. And here's why. Look at this. What's 20 divided by 4? That's 5. Okay? Still got the 3 and the x there. There we go. Just got rid of the 4. Minus, what's 20 times 1? That's 20. Okay, again here's why I did it. Don't actually multiply the 20 by the 7. The reason why I did this is what's 20 divided by 5? Okay, that is 4. Okay, then times the 7. So eventually, right, we now have this. 15x minus 20. I forgot to write the x. I'll go back and write it. 15x minus 20 equals 28. Okay, right. Right, we're going to add 20 to both sides. Add 20. We're going to have 15x equals 48. Now, hopefully you can see. Ready? Look at that. Because if I divide both sides by 15, I'll end up with 48 over 15, which reduces to 16/5. There we go. So I just multiplied everything by the lowest common denominator to get rid of the denominators. No fractions. Let's have a look at another question. Okay, solving. No fractions, straight distributive law and solve. Let's just kind of hopefully just run through this quickly. 2 times 5 is 10. Minus, what's 2 times negative 3x? That's negative 6x. Equals. Now remember, please don't combine those two. Huge mistake. It's not 8 take away 3 is 5. It's a negative 3 in front of a parenthesis. It's going to be a negative 3 using the distributive law. Leave the 8 alone. Orders of operation. Look at this. Minus 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. Okay, there we go. Just use the distributive law. Right, I'll leave that alone. We can combine this 8 and this negative 6, and this will give me negative 3x plus 2. 8 take away 6. Still got the 10 minus 6x on this side. Okay. Right. Now I like to say to myself, right, where's there more x's? Right. It doesn't really matter what side you put the x's on or what side you put the number on. Let's just have a look. I'm going to do this. I'm going to add 6x to both sides because there's more x's on the right hand side. Negative 3x is bigger than negative 6x. And look, the reason why if I do that, I'll have positive x's. Look at that. If I added a 6x to both sides, this is still a 10 over here. This is now, what's negative 3x plus 6x? That's 3x. I've got positive x's. Doesn't really matter whether you've got negative or positive. You're all college algebra students. Right. Okay. I'm now going to take away the 2. Take away the 2. That's 8. That's 3x. Divide both sides by 3. Then x is going to be 8/3. Okay. There you go. You polish that one off. If you need to, go and put it back in. Put 8/3 back here and here to check. Can be a bit of a pain, but you know that's just you proving that they aren't equal to each other. Okay, one more. Now then, special cases. Now then, I'll look at this. Some equations that have no solution. Let's have a look at this one. Right, if I add 24x to both sides, can you see, you're going to have no x's, all right? Right, what you've got here is this, 7 equals 17. No, it doesn't. That's no solution, okay? No solution. Not going to work, right? Okay, and that can happen. How about this one? If I add 1/3 x, I'm going to do it this way because I see what's going to happen. I mean, if we're going off the previous video, you can multiply everything by 3. Okay, think about that. Multiply everything by 3 because that's the lowest common denominator. But I can see that if I do that to both sides, again, I'm going to get rid of the x's. A bit like the previous one I just did. Okay, they're going to go. They're going to go, but this will leave me with 3 equals 3. Well, that does make sense. What you've got here is this. The answer is all real numbers, or negative infinity to positive infinity. Okay, all real numbers. Because you can put any number you want in there, and it will work, because both sides of the equation are equal to each other. Okay, so those are just the special cases. And that's really just solving a few examples of linear equations. Okay.